All right, let's go ahead and go through some of this homework. So let me just pick a few here. Let's look at number 1 and maybe number 7. Okay, find the GCF, the greatest common factor for each of these. So here we're not actually factoring anything out. We're just looking for the greatest common factor. So when I'm doing these, I look first numerically. So we look at the number. What do 12 and 18 share with factors? Now we could kind of do factor trees or list out all the factors. The numbers I'm going to give you, I think, are going to be small enough for you to do in your head. So 2 definitely works. Anything bigger than 2 that divides evenly into 12 and 18. Well, 6 does. So I can pull out a 6. So 6 is definitely going to be one of our greatest common factors. Now look at the variable term. So x squared. I can't pull out anything bigger than the smallest one of these, right? So that's got xx. This one's got xxx. So I can pull out 2 of those. So 6x squared would be the GCF. Let's do number 5. So here, what number goes into both of these? The biggest number. So 4 does, but so does 8. And 8 is definitely bigger. So we can do an 8, then come down to the variable. So p squared, and then q squared. I definitely can't pull out a q cube. I definitely cannot pull out a q cubed because I only have q squared here. I only have 2 q's there. There we go. And one more, number 7. The GCF of 28a to the 4th, 35a squared. What number goes into both of these? The biggest number, 7. And then what variable can I pull out? A squared. All right, so what are we going to do with that? Well, we do that because we're getting ready to pull out a greatest common factor. And so now we're basically going to do this in 2 steps. We're going to first identify the GCF. Put a little line there on this one. We'll do number 9 and then maybe number 11. So let's go ahead and find the GCF between 6x squared and 9x, just like if we had it up there. What would it be? Well, 3 goes into both of those, and then x goes into both of those. So now what I'm going to do is I'm going to take that, put it on the outside the parentheses, and then what do I have left? When I divide 3x into 6x squared, I'm left with just a 2x. And you can always sort of mentally multiply that. 3x times 2x is 6x squared. And then plus, when I pull a 3x from a 9x, what am I left with? I'm left with the 3. Now, if you need to, you can definitely write this whole thing out, right? You can write this out as 3x times x times 2. Let me redo that. 3 times 2 times x plus 3 times 3 times x. And now we can see when I pull out a 3x, that's gone and that's gone from those. So I can pull that out and I'm left with the 2x, left with the 3x. So if it helps, write that out, but don't think you have to do that. Look at number 11. 12a squared b plus 18ab squared. So again, if it helps, write out GCF. Let's just go ahead and do it outside the parentheses. So what number goes into both 12 and 18? The biggest number, 6. And so then how about the variables? I have an a squared here and an a here, so I cannot pull out anything bigger than 1a. And then I'm going to have a b and a b squared, so I can pull out a b. And what do I have left here? I've got a 2a plus 3b. And again, if it helps, and not even it helps, I really recommend boiling this back out to check it out. So 6ab times 2a is going to be 12a squared b. Then 6ab times 3b is going to be 18ab squared, which is what I got originally. Okay, factor by grouping. So binomial factor is already visible. So here, I've already grouped it up. So what is my common factor within each of these? So I have a 4x minus 1 and a 4x minus 1. That's my common factor. And so I can pull it out. 4x minus 1. And what am I left with? X squared minus 6. That's your final answer. Now, often we can actually keep going on this. This is not a difference of 2 squares. 6 is not a perfect square, so we would stop there. Okay, how about maybe do one more here? left off parentheses there. So how about we do number 21? So when I do this one, what's my common factor? Well, 7p minus 4. 7p minus 4, 7p minus 4. So I'll say 7p minus 4. Then I'm left with what? When I remove a 7p minus 4 here, that's gone. I'm just left with a p, and I'm left with a minus 9. Okay. So when they're already factored out, when the binomial factor is already visible, these aren't too bad. It does get trickier in this next little section when it's not visible. We actually have to factor out the common factor within each group. So let's look at that. Let me do number 22, and then I want to do one with a negative. Let's do 23. Okay. So I've got multivariable here, but I think it comes out nice. So we're going to group this up. Normally, you can just kind of group these up side by side like that. If it doesn't work that way, you can rearrange the terms. So what is common in both of these terms here? Well, I've got an A. I can pull out an A, and then what am I left with? X plus Y plus what's common in the next group? Good, a B. So I've got B plus Y. Now I have the same thing I had in the last little subsection. I have my common factor of X plus Y. And so I can pull it out. Plus Y. And what am I left with? Just left with an A. And then bring down your plus, a B. Okay. How about this one here? 3x squared plus 6x minus 2x minus 4. So we got to be careful here when we group this up. When we slide a parentheses in there, it's going to change our signs. Students often miss that. So I'm going to rewrite this. I don't really have a whole lot of room here. Let's see if I can squeeze it in. So 3x squared plus 6x. I'm going to say plus a negative 2x minus 4. Okay? And we've been doing this all along in algebra. I mean, when I subtract something, the same thing as adding the negative. What this allows me to do, though, is to more easily see when I'm grouping this up is when I start pulling out my negatives. So here, what can I pull out? Well, I've got a common factor of 3x. And then what do I have left? I have just an x plus 2. Now, what's my common factor here? Well, I've got a negative 2. I'm going to pull out my negative 2. And when I do that, I'm going to get an x plus 2. I'll be honest, these have to be the same in order for us to use this technique. If they're not the same, then we have to move on to another factoring technique. At this point, this is the only thing we know. And so most of these are going to come out fairly nice. And so this sort of helped dictate what I'm looking for over here. And again, I've got my common factor of x plus 2. And I can pull that out. So x plus 2. And what am I left with? 3x minus 2. So if I were to FOIL this back out, I should get my original expression. Definitely recommend checking these when you can. All right, well, I hope that helps.